Obviously, the title of this has changed a little bit since we first planned it. And this was in response to the kinds of questions that I was seeing come in from the sign up sheet. And so I will get to free and open source GIS and open data. But what I actually felt was probably more important based on the kinds of questions was simply to talk about approaches to quantitative research. Now, I've deliberately framed this in a way that spans physical and human geography. I am actually largely a human geographer, but the approaches that I use are ones that I think cover both. In a sense, I often describe myself as being at the computational end of geography. So what I do looks more like computer science than traditional human or physical. And so that's what I'm going to try and speak to. So the first thing I wanted to do was try and actually contextualize this talk within kind of the bigger picture of geography, if you will. So we have a teaching theme called spatial data science, which probably sounds even more intimidating than GIS. And I am not going to try and convince you to teach spatial data science, but rather to think about some of the interconnections that exist between computer science and geography. And I think this is an area where, there are obviously many of you probably work alongside someone who teaches a computer science program of some description. And what I wanted to point out is, in a sense, are the potential to not have to do all of the work yourselves around the NEA, and to look at ways of developing collaborations that can benefit, benefit multiple courses. So in particular, in this case, obviously within the British system, the loss of AS has had an impact on geography in terms of A-level completion, but we're not the only A-level to face challenges. Computer science especially has what we might call a gender problem in terms of the share of girls continuing on to complete their A-levels. And one way that I think about this is that computer science teaches valuable skills and geography has valuable applications. And there's some really interesting information on that report in terms of kind of possible areas of opportunity there. So I think in particular that one way to think about the kind of role that you might be able to play, even if you don't feel particularly strong on all of the quantitative elements, regardless of whether you're a human or a physical geographer, is the fact that geography really is a bridging discipline. So we work with everyone from computer science to historians, people, even I know someone who works on film, and geography does have this long tradition of critical engagement with both data and computers alongside people in place. And if you take this really big picture view, then obviously organizations like Airbnb, Google, et cetera, all are essentially making use of spatial data in various forms. A couple of my PhD students have gone on to work at places like booking.com, for instance. So I think in a lot of ways, it's actually a very exciting time to be a geographer and to be looking at the quantitative end of geography, regardless of which side of the human physical fence you might fall on. So there are technology firms, people working in smart cities, location-based services, real estate, retail and engineering firms, anything around planning, optimization, et cetera, charities, NGOs, health, obviously being a rather topical one right now, and travel, perhaps. And so this is just some material about actually some of the modules that we've taught. But what I'd really like to focus on here is this sense that by a good sort of a good approach to quantitative methods can actually, I think, inspire a wider engagement with geography, right? So it's hard if it's seen as an add-on, something that they have to go through and suffer through. But I think there are a lot of interesting opportunities emerging now. And one of the ones, this will obviously also be in when we distribute the slides later. This is in fact this is a link to something we call Code Camp, which is our kind of really foundational material that we ask our students to complete, which uses geography examples to try and teach Python programming. There's nothing to install, it runs in a browser. So, and finally, this is something that I wrote for the RGS a couple of years ago called Why the Future of Geography is Cheap. And this links in with what Mark will be talking about further. Cheap is not in the sense of lacking value, but rather this idea that the software and the code that we use is largely is in our case free. The data increasingly is open and therefore free, and it's increasingly easy to put together sensors to collect environmental information of all sorts. Maybe not quite free, but certainly close to it. And so within that kind of complex or nexus, if you will, the only thing that is valuable really is actually humans with the knowledge to exploit these tools. So if you'd like a sort of fairly light introduction overview that might get you thinking about some other ways that code can be used in geography, then I think this would be something to look at. So I wanted to first talk about the process of doing quantitative research. And I think this is a place where many people have, the teaching from certainly my experience from taking statistics classes and things was that it was presented as a very linear process. Whereas hopefully you already have the sense from Kevin's talk that whether it's human or physical geography, research is, I would say never, perhaps that's a little too categorical, let's say almost never, a linear process where you come up with a hypothesis and work out a way to test it, and that leads naturally to the conclusion. This is in fact an illustration I came across in a book about data science, but I think the same idea applies in regular sort of more straightforward quantitative research, which is this idea that there's a constant cycle, and there are cycles within cycles, and you can have feedback between one stage and the next. And actually sometimes, of course, things that you find out later feed all the way back through into things that you had thought were settled. And there are two really important points that I think are worth taking here. One is that developing expectations in this model precedes stating the question. So I think all too often we kind of jump to writing up the question as Kevin presented it, when in fact a useful thing would be to say, well, what do we expect to find? How do we, it's very close to being, why is this an interesting question? But the general idea would be that actually getting a sense of what you're trying to achieve before you try to write it down, before you try to state it in a categorical, researchable way is helpful. The other one, and this is perhaps the most important thing that you could take away from this, is that often, and certainly this is the way that I approach things, is that the modeling, which is say the statistics, comes after the exploratory data analysis, which is EDA. So I am going to have some some examples of that as soon as I get the keys detecting again. So why start with the chart? The simple reason for this is we're terrible at looking at spreadsheets. We're very good at spotting patterns visually, and sometimes we're so good, and there's a whole book on this, The Tiger That Isn't. It's a very accessible introduction to thinking quantitatively. And so I often introduce this to my students as, let's make the charts first, and then we're going to use the statistics to determine whether or not those patterns are meaningful. And whereas I think what typically happens in statistics classes is you learn that you run the stats first, and then if the stats return a good result, you then produce a chart to kind of demonstrate that. And this is, to my way of thinking, exactly backwards from how we want to do it. So I'm going to illustrate that with a few examples. This is a very famous table called Anscombe's quartet. So we have 4 sets of data with X and Y values. If I were to ask you to say, what's the difference here? There's no human being on the planet, I think, who'd be able to spot differences right away. So if we run straight to running the stats, then we see, well, they have the same mean, the same variance, the same level of correlation, and they can all be predicted by the same regression. However, we look at them and instantly spot that these are 4 very different types of data. One we would identify very quickly as having outliers. One looks like a nice kind of scattered normal Gaussian distribution. One seems to represent a curve, and so on. So by inverting this, we would automatically recognize already the kinds of data that we're dealing with, which would allow you to discount running most of the statistics that were presented on the previous page. Just to put this in another example of how charts are actually undervalued as tools for reasoning. So here we have the number of goals by a World Cup final, meaning not the final game, obviously, but the whole competition. And we see this lovely trend. But here is the same data. Suddenly that trend's looking a bit less dramatic. What have we done? Well, we've changed the Y origin from basically 60 to 0. So now we're actually seeing it in context. And in fact, we could then map it again and now we see a declining rate. And what's going on, of course? Well, if you're like your football, you would know that at various points, the number of teams playing and the number of matches played therefore changed. So in fact, we can get there a lot faster using the statistics and thinking about, using a chart and thinking through what it is we're trying to represent before moving on to the statistics to say, how might I produce a linear regression of this? How might I, detect differences? Actually understanding the data is far more important than just moving straight on to chi-square or something like that. Another nice example, this is looking at representation of women in the Brazilian Senate. We have a nice trend line, seems to be growing rather steeply, except of course, unless you think that an even 50% of women in the Senate is actually your destination. So at that rate, it will take Brazil quite a long time to reach equality. So it's very easy to lie with charts, but in my opinion, it is even easier to lie with statistics. So often inadvertently. So engaging with the actual data. I have a simple question here. Oops, sorry. So where does London end? So this might seem like a fairly trivial question, but by way of example, as soon as you start to actually try and think how you might answer that with data, whether it's qualitative or quantitative, you suddenly realize there are many different definitions. So we have here the green belt, the administrative boundary, how far you could get on, say, an Oyster card, morphology, so high-rise buildings, particular densities of people or buildings, the internationalization of business. There are many, many more. And in fact, there is a whole article published in Nature on essentially understanding how the size of cities affects various social, economic, and infrastructural indicators. So even a seemingly simple question, when you try to translate it into hard data, can become not only challenging, but actually quite interesting. So all of these types of data that I show here would give you different answers. So firstly, that drives home the idea that there is no single correct answer, which is certainly, I think, an approach that we could all benefit from keeping in mind. But it also allows us to think about, what are the meaningful variables that we would use to start to explore this question. Does having contradictory answers between different data sets, is that something that we would find useful? So don't overlook the value of simple or seemingly obvious questions. By thinking them through, there's often some quite interesting challenges in there. Good starting point for this was this, so the Fieldwork Field Studies Council obviously links to a lot of good material. This enabled me to cut a few slides from my presentation. So they've got a nice mix of human and physical geography data in there. So I'm not going to dwell on that too much. DataShine is probably one of the most heavily used websites in terms of being able to access and just get a feel for what's in the data. So identifying areas of interest. How would you decide where to go and do interviews? So having the quantitative precede the qualitative, or comparing what you've collected in the field back to what you have here. Looking at a topic of interest before you go to you go to the effort of downloading the data from the ONS or NOMIS, and loading that into a GIS, for instance. And also, these could be used as sort of working maps while you kind of customize your own data to show exactly what you want. This would, at least, because these are downloadable as PDFs, this would at least give you kind of placeholder maps. A slightly newer comer on this scene is the CDRC, the Consumer Data Research Center. You'll notice that they have very similar maps to DataShine. That's because they were produced by the same person. But this one entails a lot of commercial data, and therefore there's actually quite a lot of interesting, less obvious data here to do with things like internet usage. Some things are safeguarded, meaning that you or your student would have to apply under quite onerous conditions around data security, but there's actually a huge amount of very interesting data there. And in both cases, it's quite easy to search for relevant information. Another web-based one, which covers a kind of more global picture, is this Luminosity or Luminosity. There's actually kind of 3 connected web applications, and it might be one way of stimulating kind of thinking about comparative aspects and things like that, since this is a kind of a standard view and a standard data set covering the entire globe. And of course, Ordnance Survey. I mentioned that I would eventually get back to open data, and I'll come back to it some more later. But we can now get roads, rivers, all kinds of things. Obviously, the data sizes start to grow. So we have GeoPackages and S3 shapefiles are the 2 kind of most common formats, and also rather more manageable than GML, the Google markup language. But there's administrative boundaries, physical features, etc. So regardless of which aspects you're interested in, there's kind of something to sink your teeth into here, and all of it's available just for asking. So I think the next part of this is, I think, how do we get creative with data? How do we make it relevant? How do we bring, I think one real challenge for students is that secondary data is, especially as it grows in scale, becomes very abstract because you interact with it in a completely different way from how you might collect interview data or data from sensors that you yourself have put in the ground. In ideal world, we would do both. In the current situation, obviously that's a little more challenging. So I think one way to think about this is to think of a domain or a research topic of interest and then try and map it onto various services and data that we think might be relevant. And I'll offer some examples here. But I think there's also a lot of scope for being critical about the data. And that doesn't mean, in a sense, the age-old, all quantitative data is flawed positivist stuff. It's actually more about really thinking about how the data was generated, where it came from, and what it means. So this is an example from the Tiger that isn't. This is the OECD, a fairly sophisticated organization in terms of its data literacy, trying to get the UK Department of Health to tell them how many nurses there were in the UK. I will cut to the chase. The answer was incorrect because Scottish nurses were not included, as they were managed, obviously, by the devolved government. So that is the sort of thing where, okay, it's a nice example, but the kind of consequences and the policy implications, regardless of the kind of question that you're dealing with, of making even a sort of a basic assumption about Scotland versus England versus Wales and Northern Ireland, of course, can have very kind of pronounced long-term implications for your understanding of the process that you're looking at. I particularly like, I've been reading a new book which has free pre-review chapters available for download. I think this is one of the most exciting and accessible books I've read in a while on data. And they talk about how is the data generated, by whom was it collected, for whom was it collected, and for what purpose. But I think for a student who is struggling to understand the data that they're working with, kind of taking a step back and really sinking their teeth into these kinds of issues. And there's lots of examples in the book. Obviously, in this context, a lot of it's about issues that would be of concern to women, but the fact is we should all be concerned about these. And I think that the clarity of the book is real asset. So I think that would be a nice, or if you're having trouble thinking through the kind of critical issues that might arise, especially with human geography research topics based on secondary data, this would be an excellent place to start. Connecting with current events, obviously students, well, we're in the middle of probably, the largest single current event focus of the century, hopefully. So how, thinking more broadly, how might you tackle things like this? I have an example here from, this is a recent newsletter from the Center for Cities, saying where are the workers that can work outside the home? So a simple question, but actually, and obviously they have an answer, but one thing that I would consider in this sort of context would be, well, how would I, how might I answer a question like that? Or which cities are best equipped for socially distanced working? These are two quite, again, seemingly simple questions that require quite a bit of data, all of it's geographical, and that really require engagement with, the census and other dimensions of the data. So standard industrial code, SIC, occupational codes, and really getting to grips with travel to work. These are probably questions that would fall outside of any one student's NEA, but my point being that even thinking about how something like this might work in your own area, linking current events, the big picture, to the local scale where students can anchor kind of their analysis in areas that they understand. So secondary data doesn't have to be big. Even if it starts off big, I think that there are a lot of ways to boil that down. So for instance, on Twitter, rather than trying to capture all geotagged tweets about a particular topic, looking at what are local, what are local businesses, local hashtags, local topics, local types of users, how might we engage with them? Or, as I said, email newsletters, government announcements, blogs, etc. And freedom of information requests are always a valid way of getting data. If it's not already in the public realm on a local data portal, for instance, many local authorities and obviously the national government have, there's data.gov.uk, but there will also be local versions of that. And if there's not, it is always worth trying to find out if that data is held somewhere and can be made accessible. In fact, I just marked a dissertation which somebody had requested all of the data that King's held about them from their ID card, under a subject access request, and he'd use that as the basis for their dissertation on kind of surveillance and things like that. So I think there are lots of possibilities when you start thinking, oh, here's a topic of interest, how can I combine that with something that is locally relevant? Here's one that I now use for a lot of my teaching on that spatial data science pathway that I mentioned earlier. This is inside Airbnb. This data is not collected by Airbnb. So there are issues here of data provenance and its quality. But then there's also the fact that Airbnb does not publish its data. This has been quite controversial. So these people have, their whole motto is adding data to the debate. So you can look at it on a map. You can also download these data sets to then evaluate. And so I've had students work with, for instance, filtering this all the way down to the listings that mention people who are seeking female-only flatmates or roommates from within the whole London area, and kind of understanding what was driving those listings. And it tended to be women seeking other women that they were willing to share with, or be willing to share with them. But also could think about tourism, gentrification, etc. Also, which flats mentioned luxury. Another thing we looked at is which areas mention neighborhoods. And you'd be surprised how big Kensington and Chelsea becomes when people are mentioning that as the neighborhood that their listing is in. So there's a lot of there's things about perception. There's also a lot of hard data behind this as well. As you can see, 87,000 listings. So that's not really big data, but I think for most students and staff, it's more than enough to be getting on with. Other possibilities, and these are based on things that I've seen people do either as research or for dissertation, undergraduate dissertation. So Google Street View can include time. So students that I supervised did a kind of virtual transect of San Francisco. So they walked an area of San Francisco that was gentrifying while they were there, but then of course needed a baseline to compare it to. So they used Google Street View and basically looked at one of the earliest captures that Google had done in the area, to kind of compare basically signs of upgrading and various other types of sort of local environmental change. Google Earth, of course, includes this as well. So things like deforestation, urban growth, through the time slider. Of course, students use apps a lot. I won't pretend to keep up with what 17-year-olds are using, but Flickr, Instagram, things like that. A lot of them include location, both directly in terms of whether or not something is geotagged, but also indirectly, where was the account registered? Does the name of a city or a place appear in the description, et cetera? And so this has been, one could use this for visual methods. So actually looking at, what do French tourists look at when they come to London? People have also used it to try and measure droughts and things like that by adjusting for, how brown are the photos and things like that. Also looking at if you look at the sequence of pictures posted to Flickr, then inferring kind of the order in which tourists visit different London landmarks and things like that. Scores on the door, Yelp, so that's sort of reviews, that sort of information. One might think of looking at particular clusters of types of food, or conversely food deserts, so places where, based on the name, what's available tends to be of relatively, limited selection and poor quality, things like that. So does the changing of the name of an establishment or something imply something about local economic change? So there's lots to kind of get stuck into here. And as I said, it doesn't all need to be engaged with at the level of big data. So downloading tens of thousands, hundreds of thousands of records. It can also be, in a sense, filtered down to much smaller manageable data sets, whether by geography, things that are locally relevant, or kind of by selecting only certain types of listings as being of interest. So I think that, I've largely said this, so that kind of reflexivity of data, or approaching data with a degree of reflexivity, is probably one of the ways to hopefully empower students to move beyond a kind of, I tell my students a bit like the cargo cult mentality of, I press the button, an answer comes up, I write that answer down, and that's, the truth. And what we find, what I find as a data scientist, and what everyone that I works with and who works in similar capacity, is that, there is no such thing as raw data, and consequently, it's all about choice, it's all about judgment. And so instilling that idea that there are choices to be made, and that we try to also frame it in terms of, there's not a wrong choice, there are simply justifiable choices versus unjustifiable ones. Do you have a good reason for using that statistical test? Do you have a good reason for representing the data in that way? So thinking back to my example of, looking at the representation of women in the Brazilian Senate, why is just showing the range over which the data covers the appropriate way, versus showing, in a sense, making sure that it incorporates the trajectory that we're trying to reach of equality. So making those choices, making them conscious, I think can actually be very, very empowering. I sometimes ask my students, when they're trying to kind of get to grips with a large data set that they don't yet understand, is actually work back from the conclusion. So imagine that you've written, everything has gone perfectly. All your tests have turned up exactly what you expected. Your data analysis has gone swimmingly. What are you writing? What have you shown, and how have you shown it? And if you can break that down properly, it actually then becomes surprisingly easier. I won't say easy, but easier to work backwards to what are the sorts of things that you need to do with your data in order to determine that that's what's necessary and that's what you need to do. So finally, I said I would talk about open source GIS. So here we are. There is obviously ArcGIS, ArcMap, ArcPro has something of a lock on public consciousness or teachers' consciousness, typically because they give away largely for free licenses to schools and higher education institutions. I learned to use Arc before I learned to use anything else. and it is still a powerful tool. I won't pretend that it isn't. But if you suddenly find yourself without access to one of these educational licenses, it's a completely different story. And also, of course, the other thing that's happening a lot is that many students will now, and possibly quite a few staff will now own Apple computers. So you're basically stuck if what you're trying to teach is ARC. ARC Online substitutes to some extent and runs in a web browser, except for the fact that its analytical capabilities are fairly limited. So for me, so there's an asterisk next to free, because of course ArcGIS Online is only free if you're in higher education. So this bottom line here, so for spreadsheets, we've got OpenOffice, QGIS and Saga GIS would be the open source competitors to ARC. PSPP is an open source competitor to SPSS. We've got some tools for visualization, which I'm not going to spend too much time on, but are quite interesting. So Kepler.gl is basically Uber's visualization tool. I'll show a quick screenshot of it. It runs in a browser. Aerial OD is an incredibly powerful open source way of showing data in 3 dimensions. That'll be in the slides that I upload. And the Python programming language with what are called Jupyter notebooks, that link I showed at the start to Binder is actually, that is Python running through Jupyter notebooks. And what it is a way of running programming code through a web browser. So there's nothing to install anymore necessarily. And so to me, this is one of the kind of most exciting developments in kind of going further with kind of being able to combine sort of accessible coding with the kinds of stuff that I teach using spatial libraries, spatial analysis libraries. So here is a screenshot of QGIS. Is actually showing some research that I've been doing with Bill Hubbard, who's of gentrification research fame. So this is showing outflows from London estates. As you can see, the interface looks a bit different from ARC, but this is running on my Mac, and the all of the tools that you would expect to find in ArcGIS are also here. The migration for me from ARC to QGIS, there were some moments when I got quite confused because things work just differently enough, but I stuck with it. And frankly, I only use ArcGIS now once in a while for teaching because some of our master's students expect it. I've got some recommendations down the side. One of the really powerful things about QGIS is the plugin ecosystem. So for instance, there's a Street View plugin that allows me to click and drag the Street View person, they're up here, to anywhere on the map, and it pops open in a small window next to it, the Google Street View of that area. There are things to add OpenStreetMap base maps. So if you want to kind of put some more complex kind of full background behind this, you can show a terrain map, etc. There's something that collects from NASA, their active fire data set, which is collected via, I think it's the MODIS satellite system. So that can show you where active fires have been detected from space. Producing heat maps, so densities of points, things like that. So there's all kinds of plugins, and they're easy to overlook, but they're incredibly powerful. Chances are, if you're trying to do something, and you're not quite sure how to do it, then there may well be a plugin that makes it simple. So I personally am a big fan of QGIS. I know that Mark, as a physical geographer, is a huge fan of Saga, stands for Spatial Analysis for Geographic something. And obviously here we're looking at a digital elevation model of some description. QGIS can actually run the Saga code, so that's a solution for people on Macs. But if you want to run this interface, it only runs on Windows or Linux. Obviously, it's a bit more stripped down, but would probably be a better, less complicated interface for just kind of exploring something. This is Kepler. So this is a screenshot from my web browser. This is essentially showing some of the data that I was showing in QGIS. Those red boundaries are the estates that we found. And then there's something with the tube system. So this can be navigated in 3 dimensions. You can adjust the coloring, etc. This is obviously not a full GIS. but it does allow you to do a surprising amount of things, provided that your browser has enough memory. There is sort of after this slide, in what I'll share, there are links to basically everything that I've shown. If you are interested in knowing a little bit more about what we're doing, we've published all of the code that we use to teach onto GitHub. We blog about what we do, and of course we have a Twitter account. So I will stop there.